HVAC 360, episode number 70. Lessons learned for plumbing. Hey, welcome back, everybody, to another episode of HVAC 360. I'm your host, Matt Nelson. Yes, I'm still here. It's if you've been paying attention, I have been away for a little bit from the podcasting microphone. I have been busy, shall we say. A lot of things have been changing, and I just, between activities that I've been doing and things like that, I just couldn't get to the microphone. So I'm making a concerted effort to get back. And because I believe in sharing with this, sharing information with you guys, and I appreciate you listening. So I thought I'd hold up to my end of the bargain and start producing a few more of these podcasts. This one in particular, you might say, "Hey, did you say plumbing? I thought this was HVAC." Well, all right, you got me there. But one of the things that I was occupied with was I did a session for the American Society of Plumbing Engineers. Some of you might know it more as ASPE, but they had their national symposium, and I did a lecture on the topic of plumbing commissioning. So these are some of the lessons learned that I brought to them, and I just wanted to share them with you, my listening audience, because I appreciate you so much. A lot of times you'll have some of these crossover to what you're doing. Some may not apply directly, but hey, if you get one or two things out of this, it should be a benefit to you. Another thing, a little housekeeping point of order. Just so you know, I probably will have another thermostat operation episode coming up. It's one of these things that even I, as a professional engineer, I wrestle with thermostat operation and exactly what it is. I know last time I kind of went through and, a little behind the scenes. That episode probably, I don't know how many takes I did of it, but, I was trying to get that concept of the metaphor. So it's just something that's easier to remember and kind of understand. I didn't get it quite right. I mean, it applies to one particular set of conditions. It doesn't apply to all of them, and I just kind of wanted to explain what conditions it kind of covers and which it doesn't. So anyway, be on the lookout for the next episode on thermostat operation. I'll explain a little bit more how thermostats work too. So I guess really what we can dive into now is the lessons learned for plumbing. All right, the first one that I want to go into is it has similarities to the HVAC. I mean, it's the background, it's the space constraints that you have. In this case, we deal with backflow prevention devices. These are some of the things that come on the utility water service that comes into a building. You have the backflow prevention devices that prevent water from going, back into the system. So typically, one of the big things with the backflow prevention devices is, a classic example of something that's drawn as a line on a plan that's much bigger in actual installation. When you look at it in a house kind of application, it's kind of immaterial. I mean, something that's kind of, going to be 2-3 inches that doesn't take up a lot of space is not going to be, all that crucial. Shows up as a line. Who cares? And when you go into more of a commercial attitude and a commercial application, you're going to have something that's going to be, it's going to be 6 or 8 inch pipe that's coming into your building, for a good sized building. And those things, they need space. I mean, if you're going to turn an elbow, you're going to need a lot more space working around it, dealing with things. And the fact that, they need drains. So you take up like an entire, wall space. I mean, this could be like 6-8 feet, and there's nothing that you can really put in front of it. You need to have these maintainable. So there needs to be some clearances around there. So, don't try to just fit it in some sort of janitor's closet because it's not going to fit. these things have sizable dimensions. Another thing that's easy to kind of misconstrue is as single lines as fixture carriers. These are the things that go into walls that the porcelain fixtures, plumbing fixtures, are actually mounted to. When you look at the toilet or a water closet, that bowl, if it's not resting on the floor, is actually anchored to a fixture. And that fixture is this metal piece that sits inside the wall cavity, the plumbing chase, as it's called, the plumbing chase. So you have the fixture carrier bolted down there, and typically you're going to have one water closet on each side of that to kind of balance it out. You can have it on one side; it doesn't really matter. But that's going to be bolted down to the concrete floor. A lot of times, architects, they just squeeze as much space as they possibly can, and this is one of the things that in reality it just doesn't work. They can want that wall to be thinner as much as they want, but when it gets out in the field, these professionals are not going to install it any different than they have been for years. I mean, this is the way it is. These are the dimensions. This is the way it's going to be constructed. So that's just one of you're not going to get it any different size. And a lot of the younger architects, they just don't understand. And as engineers, there's certain things that we have to stand our ground in, saying, hey, you know what? Here's how it's going to be. No matter what you want to believe, this is it. Laying down the line. Another thing is med gas piping. Med gas piping, it actually comes in, when you look at med gas shutoff valves on a wall, say you have a patient floor that's being fed with medical gas, and that's what I mean by med gas. Medical gas, you have your oxygen, you have your nitrogen, you have your vacuum, medical air, whatever it is. For that floor, you're going to have shutoff valves to kind of zone it. And that's just the way you design it. But these pipes kind of come down the wall, go across, and then go back up in a specific way. But it takes up a lot of wall space. So it's one of those things that when you draw it, single line, you could fit it just about anywhere. I mean, the box, is probably about maybe like 18 inches wide, if that, for the actual valves, because the valves are exposed, so you can lift the plastic cover that says, hey, here's where the valves are, and you could shut it off for a specific zone if you needed to in emergency situations. But the rest of the piping is buried in the wall. You try to put that into a wall that's too short, or that it just doesn't work. It's got to move. It physically can't go in that. I mean, literally, you end up with if the spacing for the wall cavity, as far as the stud spacing goes, is one stud spacing that would fit probably the box itself. And then you'd have the pipes going, and if you had like 2 to 3, pipe sets, it might take up the next 2 stud cavities. So you'd have 3 stud cavities. If you didn't have that whole stud cavity spacing available, then you couldn't fit it, where you had it shown. So that's kind of a lot of things as far as like space constraints. If you wanted to put it in those locations. Another thing that's critical is coordination of schedules. Again, this is the same thing with electrical and mechanical. A couple of different things that is specific to plumbing is if you have a kitchen, you will typically have a kitchen subconsultant working for the project, and they will come up with the plans, and they come up with the equipment that you're going to put in there, and that's their specialty. But what they will have is they'll have a schedule. They'll have the tags on there, unique tags, mind you, unique tags for the kitchen equipment, and they will have the fixture connection schedule. They'll have, this 3-compartment sink is going to need a 3/4 inch hot water, 3/4 inch cold water, and a 2-inch drain. And so they'll have this kind of spelled out for the plumbing engineer, so they can make sure that they have all the services they need to those locations, because it's a handoff. You may have the kitchen equipment installer installing all this kitchen equipment, but it's going to be the plumber's responsibility to get it down to that connection level, that last little bit. They're not going to hook it up necessarily, but they're going to have all the services ready with some shutoff valves and ready to kind of supply there. Whether it be hot water, whether it be natural gas, they're going to have to coordinate that, and they use that schedule, and it's a very nice schedule to have. Sometimes when you're dealing with a hospital situation where you have a lot of owner-furnished equipment, such as you might have ice makers, you might have different specialty equipment, lab hoods, anything that's maybe some sort of cleaning or sterilizing equipment. Those should actually be put into something similar, where you have that. Okay, here's the tag, here's the equipment, and here's what it's going to do. Just so you're all clear on, you're not guessing. Hey, you should have this kind of connection to this piece of device. So coordination schedules for the plumbing, for the owner furnished equipment, and for the kitchen consultant, those are critical. And again, you could do it for just about anything. Coordination schedules, again, these are just, it's just they're tools to quickly coordinate when you're kind of interacting between different disciplines. It's no different than when I talked about the electrical having the mechanical equipment schedule. Something just for them to say, okay, here's the voltage, here's what I'm expecting, and here's the kind of disconnect or starter that I need for this particular device. So that's how you kind of build it around there. The condensate lines are another big issue as far as coordination. Condensate lines get missed all the time, and again, this is a tweener kind of thing. It's in between. Whose responsibility is it? Is it piping that comes from a mechanical piece of equipment that's in as far as union trades? Does it go to the pipe fitter, or is it something that the plumber has to kind of extend? And where is that exactly? Is this line of demarcation? Where does it one person's work stop and the other person's scope starts? So you need to kind of investigate that. But condensate lines, they get missed all the time. And that's a huge issue. Another thing that is big in the plumbing world is the hot water recirculation. A lot of times you might have and it's it depends on the critical nature of it. Hot water circulation in your house may not be the end of the world. Maybe you can wait that extra couple seconds. As the energy codes develop and things, are going to change with respect to this. But, this hot water recirculation for a hotel is critical. You want your occupants to be completely satisfied with what they want. And, it's a clean, safe place to sleep, and, some place where they can get, hot water, to shower in the morning or whatever they want to be. These are some of the basic functions, and if you can't achieve that, if they have to wait forever for hot water, that might be a problem. There was this one project in particular that kind of sparked this in my mind. Is we had a hotel where they had a kind of a hot water recirculation system where they distributed the hot water. It was like a multi-story hotel. They went in a central location up to the top level, and then they down-fed all the risers to these bathroom groupings, these stacked bathroom groupings. Well, up top, they really didn't have, when they did the recirculation lines would come off the bottom and then tie back in on the ground floor and go back to the mechanical room. Well, what they didn't do is they didn't balance the system. The pump was pumping, and it was just looking for the path of least return. So they didn't have that system balanced the way it should. So what you ended up with is you'd had a couple of bathroom risers that were perfect. Nothing wrong with them, and never got any complaints. And then there were some ones that were on the far end of the hotel, away from this recirculation system, that were really, it would take minutes, multiple minutes, 10, 20 minutes for the water to warm up, and that was just unacceptable. That couldn't go on, and really they needed balancing valves to make sure that, okay, you got 2 GPM, you got 2 GPM, you got 2 GPM, or whatever it took for the risers, but just to have it spread out evenly, so you didn't have that last leg being starved for hot water. Another thing that you need to coordinate: flue gases. Again, this is a material. It's a lot of venting materials that you're kind of confusing, or at least it's a scope issue. Who's supplying it, who's installing it, and a lot of times, this is, flue gases, especially, or the gases themselves. This is problematic when you have. Typically, you're going to have like a hot water heater, a situation where you have a hot water heater and you have a boiler in the same kind of area. And the problem is that you want to be able to take you might have a renovation of the boiler. Boiler's old, you want to renovate it, you take it out, you put in something that's a sealed combustion and it's high efficiency. And you may, sidewall vent it. You end up having that domestic water heater with the chimney, with a flue, the old flue, that has the totally the wrong size. And you need to be able to either, change that out to the right size, or you need to, change that hot water heater. A lot of times too, you'll end up getting mixed matched. Something that's, if they're both the domestic hot water heater and the boiler, both were atmospheric, and you change one to a pressurized system where it has a fan that blows the flue gases up the flue, you could end up just blowing, all the flue gases out the domestic water heater if you leave that atmospheric. So you can't really mix and match those type of vents or venting system when you're dealing with flue gases. The chimneys are, they're specifically sized for a particular amount of BTUs. They need to heat up, they need to convect. If you don't have that, it's going to be problematic. And lining a chimney is not cheap. So if that's something that you've missed, it's going to come and bite you back in the end. Again, this is something that usually happens in a retrofit application when some changes are being made, when something's being updated. So pay attention to that. Some of the material headaches was another topic we talked about. We had a boiler drain or underground piping. It was changed from cast iron to PVC. Obviously, it's a cost issue. And what they did this in the boiler room. What ended up happening was they didn't have the proper cooling for the blowdown for the boilers. So you guessed it. When they blew down those boilers and they changed it to the PVC, the pipe started to deform and it started collapsing on itself. So you didn't get the drainage that you needed out of that system. That was a big headache. And luckily they didn't have to move any of the boilers, but they did have to, crack open the floor and saw cut the concrete to be able to, dig down and change, that as far as they could to cast iron to really, and they added some other coolers, pre-coolers to that system. Another one that actually, so this was one of the guys in the audience actually suggested this or kind of gave this story. There was a project that he was doing. It was a high rise, and they changed out. Typically you're going to have different risers in a high rise, and the hot water riser was changed out from a cast iron or a copper. It was changed out into a PVC. It was or a plastic type material. I don't know if it was exactly PVC. Anyway, it was a misapplication that somebody didn't catch. Thermal expansion on the PVC was much greater than was anticipated with the other systems, and you ended up at the top floor shearing off the last few branches on this riser because it just expanded so much and with so much force that it actually ended up shearing off a couple of the risers and just water poured out of those systems. And I mean, we're talking millions of dollars of expense there. So be careful of what you're putting in there and the thermal expansion of certain materials. Plastics are, it's a great material if it's properly applied. Again, it's not the material typically. It's either the application or some of the execution of this material. Another issue is drains. Drains is a big one. You need to make sure that there's enough of them, and you need to make them appropriately placed. If you put it in the middle of the room, that's great for general drainage if you're washing the floor. Otherwise, you want to locate it near the equipment that's actually going to use the drain on a regular basis, whether they be boilers or whether they be backflow prevention devices. And I would kind of recommend, even though it might be a headache, I would say typically all bathrooms have a drain in it. It's going to help you out. And not only that, but you have to be aware of the pitch on the drain. You just can't put a drain in just anywhere and expect it to work. A lot of times that they'll end up, having indentations in bathroom floors in the concrete. So they'll have, the indentations there, so they can actually, as a last step, end up, putting in, a leveling compound and actually getting the floor to slope in the right direction, so everything works out all right. Another thing is sequence of operations. Typically, you're not going to deal with a lot of sequence of operations in plumbing, but there are certain things that you need to have done. I mean, especially if you're dealing with the recirculation. How does that recirculation operate? When does it stop? I mean, there's certain requirements with the 90.1 that you need to have it operate a certain way. There was an instance where I had a propane system, a propane backup system for a project, and the intent was to make it automatic. And everybody in the beginning, the owner wanted it automatic. When the natural gas, and it was a rare case, if the natural gas for some reason was to fall below a certain pressure, the propane system would take over. It's a nice system, but they wanted the automatic changeover for the propane to take up the slack. Through the design, everybody's like, yep, that's what it is. Through construction, yep, that's what it is. Actually get it installed and figure out, hey, it's not working like that. And have the person doing the startup go, no, this system isn't automatic. Everybody's like, what? The owner's like, okay, well, just, take it out of here, because I'm not going to, in the middle of winter, come out here, on a, Saturday night or whatever to, the middle of winter and start the system up and get it up and running. I want this thing to be ready and to change over automatically, so I don't have to do anything, or I don't have staff to do it. Again, it's a big issue in the expectations. Kind of, think through. A lot of times, it's not an issue. But when you're dealing with systems, and this propane system it's the first one I've seen personally. But, they're not, experimental by any stretch of the imagination. It's just that you need to kind of keep asking the questions until you get the answers to saying, yes, this is a fully, automatic system. And, end of the story is they're changing it out so, that they can have it be automatic. So it wasn't but it was more on, the propane system supplier than anybody else. Maintenance access, obviously, it's always a big one. We want to make sure that, I guess the little items that get forgotten a lot. Roof drains. Roof drains, they're a big deal as far as getting the water off the roof. If you can't get to a roof, and typically, that's where it's like, hey, there's a mechanical room up on the mechanical penthouse, I should say, up on the roof. Do we need to get up there? Well, if there's roof drains, yes, you need to get up there. Those roof drains require maintenance. And that maintenance comes in the form of cleaning. We want to make sure that they're clear and clean, and you can get all the debris away from that. If you start ponding water, that's going to be an issue. And again, it's how are you going to get there? Do you have? And there was a case that I had where it was this mechanical penthouse. It was in a high rise. It was a very tall mechanical penthouse. So we're talking probably 16 to 20 feet. Standard ladders, they're not really applying. You're going to have to get like an extension ladder. And again, this was, on one of those white PVC roofs that everybody loves because they're super slippery and everybody likes slippery roofs. But it was a hazard. I mean, again, this is up on it was a 10-story building. How are you going to get up there safely? Do you have ladder tie-offs that you can make sure that you're actually, doing this safely? Because there was certainly no ladder to get up to that high roof, and again, there's roof drains that need maintenance. All right, so that was a big thing. Finally, the last lesson that I shared with the plumbing convention was utility coordination. The utility coordination. A lot of this these are bad surprises. You want to be able to kind of ferret these out as early as possible. You want to know what the water pressure is, because if you have to add a domestic booster pump or a fire booster pump, that is bad news late in the game. I mean, it in fact impacts where you're going to put it, the space. You get the electrical on there. These are usually typically not small devices. Even worse, you have some sort of a natural gas. A lot of cases, and this may not necessarily be a big concern in warmer climates, but in colder climates, you'd have your natural gas, and you'd be guaranteed a certain pressure. That pressure will be different in winter than it will be for summer, because typically you're going to use that natural gas for heating. So your gas pressure will be lower in winter. So you need to be able to talk to the gas company and say, hey, what's your guaranteed pressure for the system? I've had a number of projects go out where typically you're going to be dealing with the big gas users. It's not going to be smaller gas users. It's going to be if you have a emergency generator that's natural gas powered, that's going to be a big one. You're going to have domestic water heaters, and you're going to have boilers. Those are all going to be critical components. And if you have a burner on an air handling unit, if you have direct fire or actually indirect fire on the rooftop units, it's going to impact you. Typically, those are a little bit more forgiving. It's a little less forgiving for the generator and than the boilers. But typically you got to get that done early. And I would make sure I had a form to saying, hey, yes, I talked. Here's who I talked to. Here's when I talked to them. Here's the information that I got. Just get it down to the T, so you have all that documented. And make sure that if the commissioning authority needs to see it, hey, you can show them that you did your due diligence, and that's what it was. Last thing you need to be aware of is that hey, if you get a substitution, in the bidding process during prior to construction, when they have all the submittals coming through, if there was a substitution and you specifically selected a piece of equipment because it had a greater tolerance for low gas pressure, you need to make sure that, hey, if they substituted some El Cheapo or anybody else's, that it has that same acceptance of the natural gas pressure. Because I've seen that happen too, where they go through and they've done all their work and they've selected it, and then they said, oh yeah, that's equal, but they forget the one thing about the gas pressure, what is running on. And that's a really big deal. So utility coordination obviously is very huge for plumbing, and not only that, but not only the pressures, Also, there's some sort of utility meters where you're going to put those inside, outside, buried, above ground. Do they have to be protected? What goes with that? So you really need to know a lot of things about the utility coordination to get your building properly supplied with utility services. All right. So that's it for this week. Hopefully you can take some of these lessons learned, apply them in a different way, and if you even have different lessons learned, you go ahead and feel free to share them. You can reach me at matt@buildingx.co. I appreciate you listening. One of the things I'll point out here at the back end, hopefully, and let me know if it does sound better, I've been working on my sound. I have purchased one of the things that kind of delayed me. I had purchased some new equipment, and I was putting those parts together, and I finally got it working. I think I have it pretty well, but just let me know if that's not working. I'd appreciate that feedback. Hopefully, and I guess one of the things, one of the reasons that I know it's this, at least it sounds better to me, is I got better headphones, and it's amazing if you listen to it in the car, if you listen to it on a computer, or if you listen to it on quality headphones. You really can escape a bad sounding podcast on quality headphones. It's just too much. There's nowhere to hide. Your ears are right there. So let me know how you like the sound. If you like this episode and you like what you've heard so far in the previous 70, make sure you give me some feedback. If you want to leave it on iTunes, I'd appreciate that too. 5-star ratings are greatly appreciated. Recommendations also. All this stuff helps get the podcast a little bit more recognized, and I really appreciate it. I appreciate you listening, each and every one of you. If you like it, pass it on. Feel free. And if you want to email me, matt@buildingx.co. If you want at Twitter, @buildingx. And LinkedIn, I've always liked LinkedIn to connect with listeners and the LinkedIn is Matt Nelson PE on LinkedIn. So, all right, that's it for this week. Thanks for listening. Hopefully this has been educational for you, and I appreciate it. And until next time, remember, know what you build and share what you know.